Writing equations in slope-intercept form. Now, you've done a lot of back and forth things, tables, graphs, all that sort of thing. And if you really understand y equals mx plus b, then you can kind of figure out some of these things on your own. But you have to make sure you have a good understanding of it. So the heading for these sets of problems say write an equation. And since these equations are in slope-intercept form, that means this is going to be the final target. And we're going to write an equation when we're given two bits of information, one being slope, the second being a point. And let's talk about why this is possible. If I have a point, and I'm just talking about this, nothing needs to be written here, and I'm over 1 and then up 5, if I only knew that, I could draw an infinite number of lines through that. But if I tell you that it has to go through this point, and then it has to have a certain slope, that means it would go up 2 for every time it went over 1. So your slope would end up making the line locked into a certain place. So that's why this is possible. But maybe from the graph you'll realize what we didn't know is where we would run into the y-axis. So what we don't know is the y-intercept. So whenever you're told to write something in slope-intercept form, it's best to set up your formula because that gives you these targets. And for this early example, above 1, 5, let's write x, comma, y. Now that doesn't mean that x is always going to be 1. It doesn't mean that y is always going to be 5. It means we just have a point that this line passes through. So if I know that I have y and I have x, well then where I see y I can write 5 because I know that I have 1, 2 of the 4 variables. If I know the slope, I have 3 of the 4 variables, which means that I can find the missing y-intercept. So I guess what I'm telling you to do is lay out your puzzle pieces and then figure out what's missing. So I'm going to write times 1 over here below the x because that's what I was talking about first. And then now I'll sneak 2 for m into there. And then I'll do plus b. And then we just have a 1 or 2-step equation to solve. And when I solve that, you could probably just figure out in your head that b would have to be a value of 3. And you're not finished because the instructions say to write an equation on the line. So as the final step, you'd want to summarize what you did. And this is where you bring in the y and the x all over again, sneak in your slope, and then add the y-intercept. So here's y equals 2x plus 3. And as you check this, it should agree with what we did. The slope is 2, and the number in front of x is 2. We didn't make a mistake there. And if I plug in 1, well then 2 times 1 is 2. And then when I add 3, I will get 5 for y, which is as thorough as you need to be on these. Guarantee it's accurate. Now we're told to write an equation of a line that passes through -4, 7 with a slope of -1. Because these are notes, I'll be thorough again. It's like I'm back 4, up higher at 7, and then my slope would be -1, so it's decreasing. So I know that this is a real thing. I've confirmed that there's definitely only one line that goes through this point and has this slope. But what we don't know is the y-intercept. And since our target is going to be to end up with something written in slope-intercept form, we know that that's the goal. So here's y equals mx plus b. Just like I said, we have an x, a y. We also have a slope, which means that we can pretty much plug everything in except for b. When I go in and I start to write all of this, I know that x is -4. I know that 7 is y. My slope is -1, and I have to multiply those two values. And I'll add b. Now you're just solving an equation. And as you solve these equations, there are, a number of different things that can go wrong. You could forget to multiply two negatives, so that's why I always am thorough and check these. So we didn't finish the problem because, like I said on the last one, we still have to write an equation of the line. So here's my y equals mx, and since I know that the slope is -1, I'll write -1x, and then I'll add 3 for b. And -1 I placed there just for being clear, if this feels like a new concept, but here I wouldn't bother leaving that -1 in there because this looks more simplified to just say -x. Again, we check it. We know that our slope is -1, and that does match what the problem gave us. And now if I plug in the only other coordinate that we've been given, a -4 becomes +4, and then adding on a 3 will give us 7. Again, being thorough to make sure that these are accurate. So that video showed us how to come up with something from, a point and when you're given slope. So now we're being given problems where maybe we have to come up with an equation when we are given 2 points. And if I look at this, we have the table, and this table shows the coordinates of 2 points. So there's an xy and there's an xy on the graph of a linear function. So by telling us that it's a linear function, we know that it stays straight. Maybe it's decreasing, maybe it's increasing. So which equation describes this function? Well, you have a lot of different ways you can go about this. You've learned a number of different things in this chapter. One thing you can do is you can just plug in values. So if I plug this in and it works in all of them, that would mean I'd have to go and check the next coordinate. But that would take a little while. So instead, let's remember that we can figure out slope when we're given 2 points. So slope is going to be the change in y over the change in x. And if I look at this problem, I can just be like, well, maybe I deal with -4 minus a -1 over 6 minus a -3. And then -4 plus 1 gives me -3 over 9, which gives me -1/3. So I could figure out what the slope is. And by figuring out the slope, I know that this is not an option, and this is not an option because it's positive. Now this is being kind of sneaky. We know that at the y-intercept, so now we got to figure out which one's correct, -2 or +2. We know at the y-intercept that's where x is 0, and I know that x would have to fall between, when it's 0, it would fall between -3 and 6. And since this is linear, it means that my y-intercept would have to fall between these values, which means that it has to be negative, so it could not be b. However, it might be nice to be more detailed for somebody to whom that's confusing. So here's y is -1/3 x plus 2. I'm checking b right here. And I'm showing this in red, meaning it's optional. So here I am plugging in -3 plus 2. And when I figure this out, I do get a value of 3. Whoops. Because this becomes +1 plus 2 gives me 3. And that means that I needed to see -1, so this didn't work out, and both coordinates should work out, so that means that b is wrong, which would leave me with a. So here, let's just try to do a lot of this in our working memory, meaning we're just going to carry it. So we have a graph of an equation that has 2 points. I'm going to plug in -1 here. Well, then I'd get +1/4 minus 8, which is not 12. So just testing out the first value helps me eliminate e. Here I am plugging in -1 here, which gives me -1/4 minus 8, which again is not 12. Telling us that f is no longer an option. And if I plug in -1 over here, I get -4 plus 8, which is also not 12. That probably tells you that H is the right answer. Jump back make sure that you make some of that stuff clear to you and add this note. So you want to check those points. And if one of them did work out, that doesn't mean that they both would work out. When one doesn't work out, that means you're good. But when one does work out, you might want to proceed with caution because they both would have to work out. And what I mean by that is, if I take -1 and I plug it in for x, I'll get +4 plus 8 would be 12. Now if you're taking a standardized test and you don't have the time to guarantee that you're getting everything perfectly correct, you might have to move on. But that would not be enough to guarantee this is correct. So then I plug in 4, which would give me -16 plus 8, which would give me -8. And that's how you would be thorough to where you guaranteed these were correct. The second video will cover word problems, but like I said, here's your target. It's like the pieces of a puzzle. Set them all out on the table and then see what's missing to figure out the remainder of the equation so that you can set it up.